Hello, everyone, and welcome back. In this lesson, we are looking at simplifying surds. And so, what we want to do is to introduce what surds are, and then we're going to go through some simple rules about how we add, subtract, multiply, divide, and generally simplify surds. So, the most obvious question, what are surds? Surds are numerical expressions that involve irrational roots. And so they are essentially irrational numbers. Now, there are some basic rules for surds. The first rule here is that the root or the square root of a product is equal to the product of its roots. So the square root of a product is equal to the product of its roots. We're going to talk about these in a moment. The second one, the square root of a quotient, x divided by y, is the same thing as the quotient of the roots. So the root of a product is the product of the roots. The root of a quotient is the quotient of the roots. And if you square a root, then what you get is just whatever is under the root sign, because the square essentially removes the root. The root in indices is written as x to the half. That's how we write a root in indices. And if you should square this, meaning that if you should have x to the half squared, then what you're going to be getting is x to the half times 2, which is just x. So essentially, if we write root x square, then our answer is just x. So if you square a root, you end up with whatever is under the root sign. So the three rules: the square root of a product is the product of the roots. The square root of a quotient is the quotient of the roots. And if you square a root, the root sign disappears. Let's try that very, very quickly. Now here we are multiplying two roots. We have root 23 times root 2. And we can simply write that since we're multiplying them, we can simply say it's the root of 23 times 2, which is the root of 46. And these would be the same. Now, if we're finding the root of 200, we can write 200 as the square root of 100 times 2. And if you're doing questions like these, it's often nice to find a square number that you can use to rewrite it. A square number makes it beautiful. So we write it in terms of square root of 100 times 2, which gives us the square root of 100 times the square root of 2. And this one we know it is 10. So we can write that as 10 root 2. And so we have simplified it. Also, if you want to simplify the root of this quotient, root 20 divided by root 5 is the same thing as the root of 20 divided by 5, which turns out to be the root of 4. And in this case, we just get 2. And when we're talking about these, we often mean that we're dealing with the positive root only and not both negative and positive roots. So here we have root of 38 divided by root 2. And we can simply say root 38 divided by 2, which gives us the root of 19. Of course, we could write the root 38 as root 38 over root 2 to mean root 19 times root 2 and divided by root 2, and then that would cancel out. We still end up with the root of 19. So there may be more than one ways to work these things out. Sometimes they cancel out easily. You could do the same thing here. All right. So addition and subtraction of surds. Now, if we're adding two surds, a root x plus or minus b root x, then what we do is that in factoring out the root x, we realize that all we need to do is add the coefficients a and b here. So that gives us a very simple template about how to go ahead and add and subtract surds, especially when they have the same root. So 3 root 2 plus 2 root 2, 3 root 2 plus 2 root 2. All we needed to do is add these, and that would give us 5 root 2. And if we're doing this one, 10 root 3 minus 7 root 3, then 10 minus 7 gives us 3 root 3. Now, of course, if we had something, for example, 3 root 2 plus, let's say, 6 root 6, then we couldn't add these two together because they don't have the same root there. We'd have to rewrite this one. We can rewrite it. So let's try that. So let's say 3 root 2 plus root 6 can be written as root 2 times root 3. And now we have a root 2 there. So in adding them, we can say bracket 3 plus square root of 3 multiplied by the square root of 2. So you only add them directly like this or subtract them if they have the same root. If they do not, then you will have to try to find a way to simplify one of the others so that you get something similar here. And then you can go ahead and add them. All right, moving on. Now, please remember that while the product of the roots, the root of a product is the product of the roots, the root of a sum is not equal to the sum of its roots. And while the root of a quotient is equal to the quotient of the roots, the root of a difference is not equal to the difference of the roots. These don't work at all. So remember not to do this. So if you get a question that says evaluate the root of 25 plus 36, you cannot split them and find the answer. That wouldn't work. So of course you can test it on your calculator to show it to prove it to yourself. So if we wanted to do this, then we would have to simply add both. 25 plus 36 is 20, 50, 61. And that would give us a square root of 61. And you plug the root of 61 into your calculator. And of course, you would get one decimal place. You'd get 7.8. 61 is close to 64. And the square root of 64 is 8. So it's close to 8. And that would be our answer there. So these rules apply to multiplication and division of roots and not to addition and subtraction. So let's continue here and look at some more. So if we wanted to, for example, simplify fully these, and remember, a surd in its simplest form is when the number under the square root sign is as small as possible. So here we have 2 root 3 times 2 root 6, and we're dividing that by 4, and we want to simplify it. So let's write it up here. 2 root 3 times 2 root 6, we're dividing that by 4. Here we can have 2 times 2 gives us 4. So we have 4 times root 3 times root 6 is the same thing as root 18. 3 6s are 18. All of that divided by 4. Now we can cancel out this 4 here, and that would leave us with root 18. But looking at our rule here, the surd in its simplest form is when the number under the square root sign is as small as possible, and certainly this can go smaller. So we can write 18 in terms of root of 9 times 2, which means the root of 9 times the root of 2, and we know the root of 9, that would be 3 root 2. And in doing this, this would be the simplest that it can go. Let's try the same thing on this one. 2 root 6. So we have 2 root 6 here times 5 root 5. And all of that is divided by 10 root 15. Now 2 5s are 10 and 6 5s are 30. So that's 10 root 30 at the top divided by 10 root 15 in the denominator. Those 10s divide out. And the root of 30 over root 15 can be written as, let me just get rid of that there. root 2 root 15. 2 times 15 makes 30 over root 15. And that cancels out to give just root 2 for the answer. So that would be the thing in its simplest form, the surd in its simplest form. Sometimes we can apply binomial products to these as well. So for example, if we wanted to multiply this out, then we can multiply using the distributive law. So root x multiplied by root x plus 2 and plus 3 times root x. Let's put that in a bracket. Plus 2. So root x times root x here would be the same thing as x. Plus 2 root x plus 3 root x here. And 3 times 2 here gives us a 6. So we can simplify this a bit. These two are similar. So we have 2 root x and 3 root x. That would give us 5 root x. So our final answer would look like x plus 5 root x plus 6. And that would be our answer in terms of this one. And we could have letters in here, and it's just the idea of how to work it out. So let's go ahead and try this one as well. So this would mean 3 root 2 minus 4. Remember, it's a square. We're squaring the bracket, so we're multiplying the bracket by itself. And 3 root 2 minus 4. Now let's use the distributive law to do it. So 3 root 2 times 3 root 2. 3 times 3 is 9. Remember, the 9 is not under the root sign. And root 2 times root 2 would just be 2. So here we have 9 times 2. And then this one times this one. 3 times negative 4 gives us a negative 12 root 2. And here, negative 4 times 3 gives us a negative 12 root 2. And negative 4 times negative 4 here gives us a positive 16. So we have here 18 plus 16 minus 20, minus 12 root 2 minus 12 root 2, and that gives us 18 plus 6 is 10, 20, 34 minus 24 root 2. So surds are actually very easy to work with once you remember the basic rules and apply basic mathematical sense. So here is our simplified answer to this. And that's it for now. Remember, if you need to get more practice, of course, there are many, many books out there that you can get more practice with, and you should, to tie down your skill. If you haven't subscribed, remember to do so. And thank you for watching.